Let's get started. Okay, as Yasuke probably already told, today we're going to talk about loading web performance of our web applications. We're going to see some of the common tips and tricks that we may do, but also we're going to see things from a little bit different angle and what could be some secret tips and tricks, secret shortcuts to supply the best possible user experience to our users and load our applications as quickly as possible. So let me quickly introduce myself. My name is Nikola Mitrovic. I work as a development lead and a software engineer in a company called Vega IT based in Novi Sad, Serbia. And when talking about loading performance, what do we mean by that? So let's say how a web application starts is we type the URL, the domain of our web application, and based on the domain, we figure out on which server we have deployed our application. And the first thing that comes into the browser is index.html. So that is the entry point of every web application. And there we have some links for the style sheets, for the JavaScript, for the fonts, and so on. So that is the first thing that we do. But getting those files over the network can be sometimes slow and expensive based on some certain conditions. And that depends on your internet speed, the size of those files, the location of the server, geographically, how much distance is between the user and the server, the number of requests we need to send to those files, and of course the user devices. Not everybody has super fast computers and phones, and we can't go and buy all of our users super fast devices, so we need to take that into consideration. So let's get started. Let's start with CSS. How can we optimize CSS? We're gonna try to reduce the size of the CSS files. And what can we do when thinking about the loading of the CSS? We could use the preload link attribute for the link tag. We could inline critical CSS so it could load as quickly as possible, that critical one. We could split and conditionally load with the media queries for the different resolutions. We could avoid direct import directly for the external CSS because it's going to block the next style sheets. It's going to load sequentially. We can use CSS modules, which are going to basically encapsulate the styles to a single component. We're going to prevent leaking of the styles. We're going to code split the certain styles, and we could use style components in React or Emotion to inject styles at runtime. So these are the pretty much common techniques to load CSS faster, and this is something that we could do with very little, Googling and research. But what the experience working on a big scale projects has taught us is that as a project goes, as a team scales, most of the CSS is being left unused. So let's simulate a situation like that. Let's say this is like index HTML, index CSS file, sorry, with some basic styles. And at the beginning of the files, we imported the whole style sheet of Bootstrap. It has a lot of CSS code there, and the whole material file. So just to simulate that situation of the unused CSS. Of course, please don't do this at your projects for real. So how would that example look in the browser? Let's say we have this application with some basic React components, and we have a big CSS file in which we have a lot of unused CSS. So how can we detect that? If we open developer tools in Chrome, there is this cool coverage tab. If you don't know how to find it, I'm going to quickly show you. There are two options. We can click here on this dropdown, go to more tools and select coverage. Or we could just click press Command Shift P and then just type coverage, and then we're gonna find it. So for this app, we have recorded. We tried to figure out the percentage of the unused CSS, and we can see here that that percentage is 98.8%, which seems about right. So how can we automatically go and fix clean up that CSS? There is a super cool tool called Purge CSS, which is automatically removing all the unused CSS. It's a build time optimization. It analyzes your CSS and compares the selectors where may you use those selectors. It is especially useful when you're using some design system like Bootstrap or Material or Tailwind or whatever. We have a safe list. If we are too afraid to delete some of the useful styles, we can put it there. And of course, we have a support for CSS modules. So let's say this is our package JSON of the React app. So probably the first step that we're gonna do is to install the Purge CSS as a dev dependency. And the second step that we need to do is just in the post build hook, we need to copy this command from the documentation. And this basically says, go to the build folder where the global CSS file is and compare the old selectors to where we may use them. So in the HTML, in the JavaScript, and put the output in this file over here. So let's see the results after that. If we run the scan again, we would get 82.8%. So we cleaned up some of the CSS. If you're wondering why this percentage is not way lower, it's because Purge CSS is not supporting nested cleaning of the nested selectors. So if you have nested selectors in your app, the Purge CSS is not going to work. But this should be good enough for optimization for certain conditions. If I would run Lighthouse check in the examples before and the example after, I would probably get 100 score in the Lighthouse. But what if that is not enough? What if the condition is lower than that? So this is the simulation. I used the throttling of the network. I used the 3G network to compare the results. So this is the before result. We got 93 score on the Lighthouse, and we can see that LCP of the core web vitals metric is getting hurt a little bit. So already there we lost some of the Lighthouse score for that 16 percentage of the differences. If we clean up with the Purge CSS, we would get 99%. So that is pretty good, and we could do some further optimizations. Some of you may say that that is not maybe that important, and I would kind of agree in certain conditions. Here I found a case study for one of the web apps some of the folks did. So in their cases, when they did some of the optimizations, it didn't help them that much. But optimizing of the JavaScript is a huge took a huge leap in the performance. So the problem is that we are sending a lot of JavaScript to our browsers, megabytes and megabytes of JavaScript into the browser, and that is really hurting the performance. So large bundle sizes will likely cause delaying during the load, the render, the user interaction, or even the page scroll. So the large bundle sizes are affecting almost all the web vitals metrics. And it's the biggest bottleneck behind slow web apps. So the JavaScript is probably the biggest problem, and it's because it's a special kind of a file. Let's say 100 kilobytes of text and 100 kilobytes of JavaScript is not the same, because JavaScript browser once it gets the JavaScript file, it needs to parse it, compile it, execute it, and needs to do some housekeeping on those files. So it's quite a bottleneck. So what can we do about it? We could with very little Googling, we could find out the result that we could minify the JavaScript, compress them with gzip or Brotli algorithms. We could remove unused code with a concept called tree shaking. We could analyze bundle size with a Webpack analyzer, so we could get a report like this, so we could see which files are the biggest. We could use some plugins. For example, for Visual Studio Code, there is a import cost plugin, which next to every import will get you the information how much in size is that import. And we can check the lib size with a super cool website called Bundlephobia. I'm going to quickly show you how it looks. So Bundlephobia is going to check the size of the packages for us. And let's go with the classic one like Moment.js. So Moment.js these days is deprecated and it's quite slow and big. We can see that it's 72 kilobytes when it's minified and gzipped. And on slow 3G networks, loading time is 1.44 seconds, which is way too much for the handling dates. And what is cool about this site is that it will get you some alternatives, so some similar packages that we could use to produce, to get the same effect to work with dates. So really cool site. And I suppose that probably most of us knows about the concept code splitting, so it's probably nothing secret about that one. So we have a large bundle of JavaScript that we load initially, let's say 1.5 megabytes, which we code split or break into smaller pieces. Code splitting could be also called lazy loading, which means we lazily load or we load on demand all other bundles when we need them. So one of the most common techniques is route-based code splitting in React. So let's say we have two pages, two routes, one index page and one rocket page, and we want to load rocket component on the second route. If we load it, if we import it like this, it's called static import, which means it's the same as all other ones, meaning that the React will bundle that component as part of the initial build. So if we go to that route, then we're gonna see that component, but there's no need to load. Let's say this component has 2 megabytes in size, so there's no need to load it initially to block this page. What we can do to avoid that is to use React dynamic import. So if we import Rocket Loader like this with a lazy import, then that component is going to be code splitted into a separate bundle, and we need to have this little suspense with a callback, which is kind of a React rule just to say what is going on in the meantime while we are loading that bundle. So if we go to the second route, then we will load that bundle only, and we're gonna offload the initial loading of the app. So that is probably that we knew most of us, but what could be a secret shortcut there? So let's imagine example like this. Let's imagine that we have an app again with 3 simple components. So this is component 1, the second one, and the third one. And let's say we knew that this third one component is causing the performance issues. So if we load this app again, here we can see that we have only one JS file, main bundle, and if we scroll down, we can see that only one bundle is loaded. But we don't want to block the initial page with this component. We want to code split it. If we run a Lighthouse on this, I already ran it before, we would get score 63. So there is some serious problem in performance with the third component. And how can we solve it? The secret shortcut to that would be component-based code splitting. So we want to split that third component into a separate bundle. So again, we lazily load it with the dynamic import, and we want that third component to be loaded when the second section is visible. So we load our application initially, we scroll a little bit down. When the second section is visible, then that's triggered to us to load the third component. So in order to do that, we need a reference to that second section, and we need some is visible indicator, which we pass second ref section of the ref of the second section as a parameter. And once that the second section is visible, then we will load the third component. Okay, let's see how that looks in practice. If we open the network tab and load application again, sorry, let's empty cache. Okay, we're gonna see that there is main bundle, and then when we scroll, just a sec. Okay, there is one main bundle, and when we scroll a little bit and the second section is visible, then we start loading of this component. If we look in the console, we could see that we have that indicator of the visibility of the second section here. So once we scroll a little bit in, a little bit out, we could see true, false for that second component. And here we can see what was the problem with the third component. I just printed all a million times in the console, which was causing the performance bottleneck. And if we would run the lighthouse in this case, we would get 100 score again, and we wouldn't block the initial loading of the page. So that would be a one secret shortcut. The other one would be the reducage of the libs that we may use. So we see that people are using npm packages for literally everything. Here we can see that there is even a library, and why should we do that when we can do that in one line of code? Surprisingly, there is also is_odd library, which has a lot of weekly downloads, and it has 6.5 kilobytes in size, which is kind of crazy. So why should we do that? Why not just write our own code for something simple? If you were wondering from before what useVisible hook is doing, for example, that is our custom hook, which is accepting the reference as a parameter. That was that second section. And we're using under the hood the intersection observer. So that is something that we get from the web API, which is just telling us is it some component visible or not. So we don't need to use libraries like virtual scroll lists or something like that. We could write with maybe 30 lines of code. We could write our own hook, which is gonna do the trick for us. And we just return true or false when some element is visible. Okay, next, images. With very little Googling, we could take advantage of the next generation formats like WebP. We could use IMG tag over background image because we're gonna get more control over it. We could create responsive images. We could improve that with the sizes attribute. Or we could load key images which are above the fold, which means initially in the viewport when the web application loads. We can prioritize them with fetch priority. We can do the opposite logic. So for the below the fold images, we could use lazy loading, and we could compress images. But what if that is also not enough? Let's say we have an example like this. We have an image of a galaxy, which is really big, and we need to display it. So if we try to load that image, we're gonna see that it takes a lot of time, like maybe 10 seconds. So this would probably not be the greatest user experience. So what can we do about it? There is a secret shortcut called progressive image loading, or low quality image placeholder pattern, which means that if we need to load image like this, which is too big, we can avoid that with the lazy image component. So lazy image, we're gonna provide a fallback, or that blurred version of the initial picture, and then we're gonna also provide the whole picture. If you thought that was the library, you would be wrong, because it is ridiculously easy to create components like that. So it's our own component. So what we do, we initially set that the full resolution image is not loaded. And while that is the case, we present the blurred version of the image. But in the background, we used a little visual trick just to hide the picture behind the blurred version, and we load it in the background. Once that picture is loaded, the onLoad event will be triggered. So that is the key. When the full resolution image is loaded, then we will load the whole picture, and then we will just hide away the blurred version of the picture. So how would that look now? If we reset it, we can see that the blurred version is loaded much faster. We can see the blurred version, although the full resolution picture is being loaded a lot more. And once it's loaded, we display just the full version. So that would be about the images. Mostly when working on a project, we communicate with some API, and we could sometimes that payload is too big, so we can reduce it with the GraphQL or prefetching of those data. But what if not? That is not enough. We could prefetch data using the use SWR hook. So let's say we have the example that we have application with a link on a home page, and on the second page is a page that is fetching some heavy data. We could have that link, and when we hover that link, we could trigger the request. So in the example that I'm about to show you, we have we're communicating with a NASA's API to get the all possible habitable exoplanets. We send that request, and after we send that request, we use SWR to cache that response with a mutate function based on the key that we provided. And in the component that would, let's say, display that kind of list, we just call that cache from use SWR config and get the data by the key. So that's the same key that we provided over here. And as you can see, this component is not sending a request, and is not getting a prop from somewhere. It just pulls the data from the cache and renders that data. So we're gonna see that example over here. So this is like Svemirko in Serbian means spaceman. So it's a little bit of futuristic app where we could go to this app and explore the universe, explore the possible planets that we want to go to the vacation or something. And while I created this little distraction, maybe some of you noticed that I hovered over this link to prefetch the data for the next page, which is heavy and can take some time. But if I click it now, the data is immediately there. So there is no loader, there is no waiting for the user. Data is immediately there. And one of the two most common patterns for the prefetching is once when you go to the page, you start prefetching, and the other one is hovering over link, because that is kind of a signal of a user, hey, I'm about to go to the next page, so I'm going to need the data pretty soon. Okay. Since while we're at caching, caching is a mechanism where we, again, load the files from the server, but if those files haven't changed in the meantime, there's no need to go to the server again. So caching eliminates network latency. It only affects safe HTTP methods like GET or HEAD. And we have some cache control headers that we need to set up on the server, which is serving our files. So in the response, we're gonna get some headers. They could be no store, so never cache anything, no cache, which means send the conditional get request to check if there are new files, new version of the files. We could set the max age, the duration of the cache, and we could use stale while revalidate cache, which is SWR, hence the name of that hook that I previously showed you. But the problem with the cache is we have limited control over it. A secret shortcut for that would be service workers. So service workers are going to intercept the request between the browser and the server. It's going to act like a proxy. We have more programmatic control over cache, and they offer us offline capabilities and performance improvements. And there are also all kinds of different scenarios. If we go to this link, we're gonna go to the website called serviceforkey.rs. So it's a Serbian website, but it's amazing because it has all different kinds of scenarios what you can do with service workers. There are a lot of useful stuff over here. So I highly recommend this resource. Okay, and of course, when talking about performance, we need to mention server-side rendering, which means when we go to the URL of our app, we don't need to load the whole bundle of the JavaScript. We could calculate some of the results on the server. So based on some dynamic data, we calculate the HTML, the output of some action. We get that HTML back to the user. User gets results as fast as possible, so he can immediately interact, look around with the app. And after that, we just hydrate that data. So there is a pattern called progressive hydration, where there is a stream open between browser and network, and we just load some functions, attach event handlers as an actions to the HTML that we already loaded. And the leaders in this field in today's development are Next and Remix, which both have some similar features like these. They have some differences, of course, but we're not going to talk about them today because it would take a separate talk for only that one. But what is the secret, ultimate secret shortcuts, and why we should use those frameworks is the concept called edge computing, which means, for example, if we have a user over here in America, we have server here, that's going to be the response for that is going to be pretty fast. But what if we have users across the world who need to communicate with this server? So we invented a concept called CDNs. So it's like a bunch of servers that have replicated data, so they could deliver the files to the users geographically as close as possible. But if we need some data which are based on some kind of a dynamic logic, we still need to go to this server. So what Remix and Next are doing is they put those that logic on the edge, meaning that they break our application into serverless functions, and they deploy those functions as lambdas. For example, if you're using AWS all over the world, and we get the responses as quickly as possible geographically based on the user location. And at the end, we have the best performance hack ever. Be prepared, this is gonna blow your mind. So it's this one. So we just put a timer around every important action for the user, and we just move away those timers after some time, and we're good. Everybody's gonna love us, especially our users. And since we're JavaScript developers, we're not going to use thread sleep. We're going to just use set timeout with 5 seconds, which we're going to delete them afterwards. So that would be all for today. Thank you so much for hearing me out. If you have any questions, or maybe you want to talk about performance, you can find me on this email. And all examples that I showed you today are on my GitHub. So if you just scan this QR code, the link would lead you to my GitHub account with all the examples from today.